colleague Candice Chung will present more on the application of geospatial, the one map, the one triggered by the involvement of the youth, as well as including the pitch on the data side and the analytics side, entrenched in all of these. So over to them, and I hope you enjoy the live demonstration that they prepare for you.
I'm sure we will. Thanks. Richard, please.
Yeah, thank you very much for that amazing introduction, Alex, and thanks a lot for everyone who has joined in today. The conversation, as you've already heard, with the youth, with half of the world's population under the age of 30. Very, very timely, but it's always said with all the global agreements that we do have in the world today, it's best summed up in an African proverb that says, if you want to go quickly, you go alone, and if you want to go far, you go with others. And so citizen science is very, very crucial and instrumental, not just in terms of being a strategy, but actually complementing the already professional data collection, which can only help to bring impact to scale. And so with that, it becomes very, very important to look at the state of our global environment, because as we gather here today, the discussion on youth, very, very instrumental. They are living in an environment where the air quality, that the air that we breathe, to the waters that we drink, and to the ocean's health and coastlines, they are actually under siege. And therefore, as a result of this, we urgently need to address data gaps, so that at least as we monitor data to be able to close and drive action, we do so having all the gaps been closed. And this takes us now to the example of water quality monitoring, which is currently an aspect that the global environment monitoring systems under the early warning and data analytics branch of UNEP is undertaking across the globe. But what we see is that 75% of all the water bodies currently monitored are actually in 24 high GDP countries, whereas only 1% is in the least developing world, and mostly in the global south, with most of the countries in the African continent. But we know that it is estimated that the global environmental monitoring needs surpass 25 billion US dollars. What does this mean? It means if we do not leverage citizen scientists, then definitely we will not have an affordable means. And to increase the temporal and spatial data collection, we have to bring in citizen science. And that is what the UN Environment Program, Global Environment Monitoring Systems, are focused on, leveraging the citizens science work to be able to close data gaps, to be able to ensure that at least we drive transformational actions on the ground. And we've done this across 5 countries. And in these 5 countries, through the James Water Program, where the focus is on monitoring water quality and responding to SDG 6.32 indicator, is very, very crucial. And we've done this in Malawi, we've done this in Sierra Leone, and especially focusing on the Rockell River, where monitoring of that and engaging citizen scientists have covered 34 sites. And these sites of the river catchment have provided information that they have actually integrated into the monitoring of the SDG 6.32. And more importantly, what is exciting is the Sustainable Development Goal 6.3.2 report preliminary results do show that the water quality monitoring as we speak today is actually further degrading. And if nothing is done, within the next 6 years, we'll have about over 4 billion citizens at the risk of health. This information has helped to inform the submissions of countries. And we have 2 countries that are leveraging citizen science to inform and complement data from satellites, from technological tools. And this is an example in the entire world that has actually happened from the James Water work. And it's resulted to an increase from 18 to 34 water bodies being assessed as we speak today, and a jump in water quality measurements from 354 to 694 annually. That is really an opportunity to showcase that citizen science data collection to close data gaps is urgent. But as we do this, one of the most fundamental aspects that we need to understand is that we also need to do the same for air quality. As we're speaking, we have open source data that is showing air quality data gap needs to be closed. And we're engaging citizen scientists working with students and young people across schools and installing sensors so that at least they can be able to gauge the air quality, so it becomes part of school curriculum. And this is quite very, very instrumental. The second aspect is, as we do this, there is a gap because the monitoring is focusing at the mainstream. And therefore, the experiences from the mainstream, from water to air to ocean, have also come with an aspect that we need to cover, which is the upstream risk. Because the upstream state of monitoring, leveraging citizen scientists, is quite very, very instrumental. And that takes us now to an entry in an innovative approach, an initiative that the UNEP is championing at the moment called the Early Warning for the Environment, which focuses on beyond the coverage of just climatological and meteorological risk, that we have very well established early warning systems to now to look at the dimension of pollution, the dimension of biodiversity and nature loss. And it is in covering these aspects that the early warning for the environment approach comes in. And it comes in at a time whereby in the world today, we do have data at the mainstream. But to cover this, there are 4 aspects that we've learned from leveraging citizen science within the work of the Global Environment Monitoring Systems, UNEP. Recording air quality in the entire world, we have up to 6,000 cities that monitor air quality, that we know. But the air quality is at the mainstream. And as we're speaking today, 90% of global population still breathes air that exceeds the World Health Organization quality limits. So what is the implication? It means that the data at mainstream, though we have it, that is showing the quality of air not good, we need then to forestall where the problem is coming. And that is why monitoring at upstream is the new direction that we're moving into, to leverage citizen scientists to be able to monitor and give us the data. For example, across the world and in the African continent, citizen scientists in Cameroon and Nigeria have already been engaged to mobilize local structures that are accessible to people, like communal cooperatives, and they are actually monitoring upstream risk of pollution, like charcoal burning. Where is it happening? Waste dumping, where is it happening? Waste burning that is resulting to nitrous oxide, where is it happening? And they have trained actors who are actually determining this information. And they are also incentivizing themselves to then be able to participate. Because one of the things we've learned with the work on citizen science is that without a business case to incentivize citizens and provide trainings to them, it becomes very, very difficult, because then we might not always have the financial resources to engage them. But when we make them to see that the action they take, the data they collect, the activities they engage in can put money in their pockets and food on the table, then that becomes an incentive. And we have actually seen this in full swing, whereby communities intercepting waste at upstream are turning that waste into biogas. And that is helping them to come up with clean solutions that are fetching the money, like biofertilizer from waste, like biogas that is replacing dependence on charcoal. And one of the aspects that we've also learned in Cameroon to Nigeria takes now us to the third part, whereby standardizing citizen science data becomes important. In James Water work and the World Water Quality Alliance, what we are actually doing is that we're working with Earthwatch Europe, and we are seeing that citizen scientist data can actually become instrumental when there is a unified standardized methodology. And this is being developed at the moment. Already Zambia and Sierra Leone, as I said, have used this methodology to engage citizen scientists. And leveraging this approach is the same thing that will take to upstream to be able to measure upstream aspects. And now with the advent of artificial intelligence, with digital twinning, integrating this aspect and this engagement with citizen scientists will become very, very important. That takes me to the fourth point, which is leveraging citizen scientists to complement technological solutions. As we're speaking today, open source data, whether it is air, that we have IQ Air, we have AirQO, we have artificial intelligence technology, digital twinning, the focus is mostly at the midstream. And therefore, midstream data must then be matched with the upstream. And we need citizen scientists, what we call boots on the ground, to complement technological data, to get the information, to inform and leverage simple approaches like WhatsApp, where communities can see waste affluent leaching from farms where chemicalized fertilizer has been applied, and send the information in real time that can then be captured to intervene, and that data can actually appear on a dashboard. For example, like the open management system, data management system that has been developed for air pollution monitoring that we are actually driving. It therefore means, with the lessons we've learned with citizen science, with the data that has been collected that is now being captured to inform the Sustainable Development Goal 6.32, what we need to do is that citizen science strategy, though it may be slower, is actually bridging environmental monitoring data. The fact that it is also accessible to the communities, and especially in the global south, should actually be leveraged and complement this with the professional data collection that makes use of expert manpower and with sophisticated technology. But what we're also seeing is that the magnitude of the impact of coverage that actually are cost effective should actually become the norm and not the exception. With this, we think we can make a big difference. Thank you very much.
Dear Richard, thank you very much. This was an excellent presentation, and it's really so inspiring to see that the concrete work that you are doing. And when I heard terms like business case for citizen science and doing the corresponding training and standardization of citizen science data, and so these are really such important topics, and that you are already working on it, that we have the partners from Kenya, Caroline, who said that she would work with us. So we have huge opportunities, and we will also work on a mobilization of the relevant resources. I firmly believe that we can be successful together, and thanks for supporting all the cooperative efforts that we had so far and for the future as well.
Shall we give the floor to Igang Lee? I'm amazed. I'm always amazed when Richard can build the bridge between actually implementing things on the ground in the global south, in countries. He mentioned several countries in Africa, from Malawi to Tanzania, Zambia, Sierra Leone, and actually the power to do it, to provide capacity building to communities, the participative approach that he was mentioning, and then linking these to the global platforms, to the early warning platforms, monitoring platforms for air, for oceans, for water. Always amazed. In this arena, let me give the floor to Igang Lee and to Candice Young, that will demonstrate more on the side of geospatial, one map, data, and the connection with the youth.
Thank you, Alex. Thank you, Jeff.